Yeah. All right, let's get started for the afternoon session. And this session, we will focus on how will AI change our cities and planning practice. So the first presenter is Konstantin Soda from New York University.
Thanks so much. Yeah, thank you. It's great to be here, and it's exciting to have this opportunity to speak to everyone about AI and urban planning. I'm a professor over at NYU, and I also spent a lot of time at the Center for Urban Science and Progress, where I still am, where I led one of the first kind of urban informatics programs. So one of the first programs focused at this intersection of urban and data. A few years ago, I wrote an article in the journal Planning, Education, and Research, Urban Informatics and the Science and Practice of Planning. And it's amazing how quickly these things start to outdate. So part of this talk is to catalyze a revision of that way of thinking and to kind of set the stage for what I hope to be somewhat of the discussion around these new directions in planning and how urban planning as a field could take a bigger leadership role in defining how we integrate data and computation into the urban space. So just for a little bit of background, just to kind of set the stage of kind of where we are and how we got there. We don't need to go back too far and to look at the 1950s and the rational comprehensive model and the introduction of systems dynamics and urban dynamic models. There's a lot of great histories of those of kind of the evolution of data in the urban space that are out there. But what's interesting, I think, is looking at how things have changed since the late 2000s, when we really started to see the emergence of smart cities and big data become the buzzwords, right? And here you had the legacy technology companies coming in, seeing kind of the global urbanization as a way to generate revenue, to generate new audiences, new customers. And we start to see kind of the evolution of this intersection of cities and data. This is also when we start to see new urban programs emerge, such as CASP, this work that Jeff West was doing at Santa Fe Institute around the science of cities. So we start to see this kind of emergence of it, very much kind of in the vein of experimentation of different fields, particularly physics, kind of looking at the city as a unit of analysis. By the late 2010s and into 2020, we start to see the smart cities in practice. We see the rise and fall of things like Quayside in Toronto, some of the eco-cities that were proposed across the globe. We begin to see kind of what the limitations were of some of this in practice, but we also see the evolution again in the academic sphere. So NSF introduces its Smart and Connected Communities program to try to fund this work more directly. The PCAST report talks about technology in the city and kind of brings the federal government more into this. And we also see a wider diffusion of data-focused programs, concentrations in planning programs, specialized master's programs in urban informatics and urban analytics, et cetera. And so now we're at this part where we're in this almost post-smart cities environment. AI, of course, is now mainstream. When we look at kind of the Google trends, the blue was big data, the red was data science. Data science is already starting to be on the way out. So the hot new topic, of course, is AI as the new buzzword. And as was alluded to earlier, we're very much in this hype cycle around AI. So the focus, I think, for us as a field, as a profession, is to be thinking about how do we just not follow the trends on this and actually establish a longer-term research and practice agenda that will create some unified approach to thinking about how we integrate data, computation, and artificial intelligence into urban planning and into the practice of planning for cities more broadly. So I'll go through some of this very quickly. I mean, obviously what's changed is we've moved from this very static environment in terms of the data resources to a much more dynamic environment. So high spatial temporal resolution data, increasing flows of that data that require new abilities to process that information through new tools, new computational infrastructure to be able to make sense of all of that. And of course, the technologies themselves that generate all this data are shifting how we interact with the city. So there is this kind of endogeneity that's happening in terms of the technologies that are creating all this data are also shifting how we interact and understand and behave within cities. And just examples, I'll quickly touch on some examples of our work in this space. This is environmental sensors that we put out on Governor's Island and integrated that with Wi-Fi probe request mobility data. Looking at exposure density around COVID, using high scale or high resolution mobility data and geolocation data, understanding neighborhood change using geotag social media data. So all of these that were kind of touched on this morning in some of the presentations and a lot of the work that you all do, all of these new data streams require new ways of understanding and could unlock an incredible opportunity to understand how the city functions, why it functions, how people behave in cities, and how the built environment ultimately influences that behavior. So as one of the things that I did earlier on was try to create a topology of data and computation in the urban space, breaking it very roughly into kind of operational problems, which are very much the predictive and optimization problems that the smart city boosters at the very beginning were trying to push. You know, how do we optimize flow of traffic, flow of energy? How do we connect resources on demand? The broader policy issues, how do we engage data into analytics into policy design and implementation, and then the longer term planning issues as well. So I started with kind of looking at the complexity across or the spectrum of some kind of related issues in this, and now looking to expand this into kind of the data needs to address these types of problems, the computational requirements needed, and then increasingly the human and social risk involved with actually the application of these types of models and tools into planning decisions. So again, I'll just quickly go through some examples. I could talk about these another time, just looking at some of the work that we've done on kind of city management or kind of operational type problems. Really interesting kind of opportunities in the data-driven urban policy space. The policy innovation that's happening around city climate action is very compelling. And what's interesting about this is not just about the tools and the methods, or it's not just about the analytical results, but it's about building the data ecosystem to create a policy that actually is based on performance, based on measurement, and based on these feedback loops that would eventually emerge. And what's interesting, when you build that ecosystem, it also creates the data to ask and answer bigger and broader questions. So one of the things that we've come out here, of course, after looking at this now for 15 or so years, we've learned a lot of lessons about why we can't talk about data solutions too much, right? That was the semantic line for many years of we could solve problems. And of course, those solutions haven't really panned out. But there are a lot of lessons and constraints we could take from understanding looking back over the last few years. So one, as we all know, in many cases, the right data are rarely available. We're still trying to use data that was designed and collected for other purposes to ask new questions of. And so this creates a lot of limitations. And some of these relate to kind of data provenance. So understanding how that data was collected, why it was collected, for whom, which then leads to issues of representative bias and other issues that are embedded in the data itself. And of course, those types of biases propagate through. So when you have biased data, you create biased models. You could add to that bias based on the model that you use, and then that ultimately influences the output and the decision at the end. So increasingly, actually not increasingly, decreasingly, but we still see, of course, integrating. Some of the most interesting work happens from integrating different data sources, and that is limited, of course, by the kind of silos that have been created. And cities agencies themselves, who often are, for many of us, our clients, our partners, our collaborators on this work, face a number of barriers to actually be able to implement data-driven type work and AI more broadly into what they do. So one of the things I wanted to kind of put out there, and this is really just a prompt to hopefully start a discussion and start the discussion for the rest of the afternoon, was thinking about how we move past this name game of going from the hot buzzword in terms of how we approach this, what we teach our students, the research that we conduct, and going from an ad hoc incremental approach to something where we as a field, as a collective of researchers who are doing this work, set an agenda and set an approach to actually answer some of the bigger questions. So I think that one of the things we should be looking at is focusing on this concept of a computational urban science. And why? Because the urban science is about more than just the data and the AI and the tools and the output. It's about a new path of knowledge discovery, how we actually ask and answer questions in this environment, the kinds of questions we could ask. It's about a new way of conducting research. When we take these lessons from kind of the more traditional sciences about interdisciplinary teams, large teams working on big grants over a long period of time, or on bigger problems. I mean, this could and should, I think, in my mind, apply to kind of urban planning, the urban planning field as well. New standards for how we disseminate results, even things like making sure all of our data are publicly shared and code is shared and it's reproducible, and that is a standard part of the publication process. And we're starting and increasingly seeing that in journals as well, but expanding that and really bringing that to the fore in the urban planning field. And of course, underlying all this is a renewed emphasis on understanding the bias and the moral questions that underpin so much of what we do as urban planners. But how that, again, how those biases propagate through the data that we use, the models that we choose, and what that tells us. And ultimately, it's about focusing again on big ideas. Susan Feinstein talked about the new modesty in planning many years ago. I'm not sure if we're past that new modesty, if it's an old modesty or where there is no modesty anymore. But getting back to this idea of a big idea, right? I like to show this sometimes. It's just, this is the difference in life expectancy in New York City communities. 15-year difference based on where you happen to live within New York City. We could all give some explanation from our own disciplinary lens or our own experience about why this is, but we don't have a holistic understanding of the complex interactions between the built environment, the natural environment, and the human environment to understand and to make sense of this and to deliver actual effective policy and planning decisions to do something about it. Now, I know that that is a very loaded thing, and I know that this is all can be and needs to be segmented across lots of different fields. But it's about getting at these big ideas. Like, can we figure this out? Like, that could be a prompt for what we think about doing for the next 5 to 10 years. And so how do we actually move forward with more concrete steps? I mean, one is around education. It's been interesting to kind of see the evolution of this. And when CUSP started, we didn't actually have much influence or input from the planners. I don't know if that's because the engineers and physicists just push them out or don't let them in, but there just wasn't much engagement at the time. And we saw this around a number of other programs that emerged at that point in time. So one thing that we need is, of course, the planning field to take this on much more squarely. And we see a number of concentrations, for instance, in smart cities and other things that are popping up, but really embedding this into kind of how the field trains its students. And I think one highlight of this is I come across a lot of PhD students, as many of you do, and they often struggle to find a home for this type of work. Where do they go? Do they go to an engineering school that maybe is a little bit more social science oriented? Do they go to a planning school that hopefully is more technical? Do they just end up in a data science program? So trying to figure out where that PhD student who wants to do this type of work at the intersection of AI and planning can really be, and designing a program where that person would fit. I mean, I think that would be a measure of success in thinking about what we're doing in terms of teaching and training the next generation here. And another important piece of this is with generative AI and all the capabilities it has, teaching coding is no longer necessary. Teaching the models isn't necessary. You could just run a prompt to say, run a neural net model on this data set and produce a presentation on the results. So it's even more important to understand, to know when the models aren't right, to know the right questions to ask, to say, is this really what we're trying to get at to address the problem at hand? And that gets back to, a tension that I continually see, which is this kind of tension between focusing on the data, which is where the computer scientists and folks want to come from. They're just interested in these large data sets, and they are very compelling and very interesting. And then what urban planners traditionally do, which is focus on a problem. And so we need to reinforce that focusing on the problem, that the model and the data should come second. I've reviewed a number of papers in planning journals recently where it was all about testing 6 different machine learning models and saying this one had a slightly better R squared or pseudo R squared. And so therefore it's the best way and this is the best fit and I've solved the problem. And it's like, should not be something that gets to the point of a planning journal, right? That shouldn't be the mindset of someone who's doing this type of research. So that I think is critical. Practice. One thing, the challenge in practice is integrating the kind of experiential knowledge and the data-driven knowledge. And there's always going to be pushback on that. And I am not keeping time, so somebody needs to shut me up at some point. The experiential-based knowledge and kind of this data-driven knowledge and integrating the two and thinking about, instead of the human in the loop decision-making that's become very popular, where the human is as additive to the model. The model is prioritized, the AI, the algorithm is prioritized, is flipping a script, where it's still the human decision-making process, where the algorithm itself is actually supporting and complementing that process. And then another piece in practice, and what's really interesting, I think, and emerging now, especially of what we saw from the failed and semi-failed kind of smart city in practice models and some of those developments, is planners really understand the infrastructure layer well. We know how to design roads, and engineers collectively. We know how to design roads, put in sewer infrastructure. We understand how to create policy and regulation. This data layer, how do we integrate the technology and data into this, is still something that needs to connect the two. So how do you connect the physical with the cyber in this case? And how do we link those in a way where they're not just, where the technical, the data piece, the technology is not just being added on? Yeah. And then finally, I just close quickly with kind of the direction for research. And I hope that this will, again, lead into the conversation in the afternoon. Tom is talking about a new research agenda as well. Thinking about where these opportunities are. One, there's a whole new set of funding opportunities that should catalyze some of these other ways of interacting and working in interdisciplinary teams and thinking big, thinking larger scale. Thinking about ways you can increase opportunities to collaborate across disciplines within your institutions. And I know this is a really sticky subject, but it's incredibly important. And then even small things like the way journals set the standard, but another last piece of this, beyond thinking about a broader inclusive research agenda, is also thinking about data access and data infrastructure specific to urban planning. I don't know how many of you have ever worked with, let's say, smartphone data, but it takes months to clean it, to make sense of it. And each of us are doing that and wasting all of the work and all the students' work and trying to recreate this. If we had an infrastructure and a repository where we could share this data, where there was a way to incentivize sharing this data, where we could cite and be responsive to people who are putting the time into using and making this data, this would go a long way into helping us catalyze and accelerate more advanced and more sophisticated research in this space, and hopefully more, get at those big questions a little bit more broadly. So thank you very much.
Yeah, thank you. Very insightful talk. And basically, it's a great start for the whole afternoon sessions. Yeah, basically cover all of these things. I think we still have time for one question.
No, we don't.
Oh, no. How about people here? Yeah, Joe.
What's step one?
What's step one? That's a good question. I'm going to start with the students, because it always starts with the students, right? So I think it's about making sure that the students that want to do this work can find a home within planning programs and within the planning field, and especially PhD students. So that might be, organizing, faculty who are doing this to kind of work across schools and across the field. But that's an excellent question. And in fact, I'm giving you some sort of a BSy answer, but the truth of the matter is there are a few different step ones. There's a long way to get there. Yeah, I'd love to talk to you about that more. Yeah.
Thank you. And we are going to move to second presenter. Karen Chappell and Matt Luke. Oh, I'm not sharing screen.
When we get set up, I'll just say that this is actually, you get a twofer for this one. It's two different papers, one by myself and some other folks and one by Karen. We got sort of
10 slides in total.
Yeah, with just 10 slides. John, don't look at the presentation, you'll be happier. But we're professionals. We know how to get through, the 55 slides we have. So no worries there. I'm Matt Zook, by the way. I'm, have degrees in city and regional planning, but I'm actually in geography right now. So hopefully, yeah, okay, so hopefully that's all going online as well. Start my timer to make sure Karen has a chance. This is, both of us, makes sense for us to be together. We're both talking about sort of some black box sort of bias and sort of issues around there. Particularly, the project I'm going to be presenting, and just to let you know, this is actually sort of a preview for my presentation on Friday. I'll go into more detail, use the same slides though, is really about how digital systems end up representing material places, material people, things like that. There's a lot of interesting work on here. I might just like toss out, highlight Sophia Noble's work on some algorithms and sort of how they've been affected by sort of racially biased data. Wendy Chung has some really interesting work talking about how algorithms perpetuate these biases over time. And I guess just sort of quick go, the goal is really for this presentation project is to think about how to see or test what's happening with generative AI, LLMs in particular. I'm not going to talk much about how these work since I think most people have a pretty good sense of this. The one thing I do want to emphasize is how, in our argument here, bias is essentially a structural feature of LLMs. You're not going to get away from it. It's based on the data. I think there's some really interesting questions about how you might address bias and try to, keep it from overshadowing or producing particularly problematic results. But that's about putting in another set of preferences or bias towards that. There's a whole interesting thing about reinforcement learning from human feedback, which is essentially teaching ChatGPT to be polite. And what we were really trying to do is to get around that politeness and get what AI or ChatGPT in this case really thought about this. We're going to be talking about, our next steps are looking at other AIs. We're just looking at ChatGPT for this. And the challenge we faced was getting ChatGPT to actually give us clear opinions. If you've ever asked ChatGPT anything, questions like this great question, very loaded, which country is more corrupt, the UK or the US? You get this sort of waffling response back, a wall of text that says, well, you got to look at this, think about that, and all that sort of stuff. But you can get it to make a decision or make a ranking. US won, so yay. If you use the right prompts. So we spent a lot of time thinking about prompts. I'll show you what we did for that. But the overall methodology was we built a custom-built ChatGPT engine or query engine to query the API. In particular, we're using the 4.0 mini API model. We chose that largely due to cost concerns because we ended up running over 20 million queries for this project. So cost was a big factor. We had a small grant, but not that much money. We were doing a whole series of comparisons, asking ChatGPT to compare back two different geographic entities, countries, cities, states, some other ones you can see them listed up here, neighborhoods as well, over a whole bunch of different categories. And we tried to come up with a different set of kinds of questions, some that are highly subjective, some that are highly objectionable, some which are, much more straightforward. So we did this comparison back and forth. Those are the query instructions in case you're curious about how we did that. We did 20 million queries, and essentially we compared each geography, the US and the UK, the US and France, the US and China, which one is, so forth and so on. That's why we had so many queries. We did that for robustness because when we tried asking ChatGPT just to give us a ranking, it sort of petered out around 20. You've probably experienced something like that. And we also realized that sometimes the order of the country or the two comparisons made a difference. So we switched the order, asked it twice, and then we came up with this ranking system that if for the two queries that were done between the two countries, if the same one or the same geographic space, if the same one won both times, it got a point. If you lost both times, you lost a point. And if there was inconsistent or a non-response, it was 0. So from this, we were able to get an ordinal ranking of ChatGPT's preference on a whole bunch of things. So I'm going to show you some of the results in a bit, but first I want to go into this because this is really sort of the takeaway that we came out of from this research, trying to categorize the different sort of types of biases we're seeing. Some of them, I don't really have time to go through this. Availability bias is really just like what's the nature of the data that the LLM is using. Pattern bias is less about how much data there is as an availability bias, but more about how the data is structured, what are the sort of the co-occurring words and so forth and so on. Trope bias, I think, is probably one of the most interesting ones here. This really gets at the reinforcement learning by human feedback, where we're teaching these LLMs to be polite. It's sort of benign stereotypes is what we mean from this. It's not it's things that, you know, they sort of smoothed away or not taught ChatGPT shouldn't talk about things in certain ways, but then there's still lots of sort of residual kinds of things that are not as objectionable and so doesn't get sort of caught up in the same sort of way. There's some other things, but I'm sort of getting close to my time, or end of my time. So let me just give you a couple examples. So we did countries, states within Brazil and the US. One of my co-authors is Brazilian, so that was part of the reasoning there. But did a lot of them countries. So this is one of the queries: or where are people more artsy? And this is where we think is a great example of this availability bias, because particularly China stands out in this particular map as being sort of mid-range and sort of artsy, which doesn't really make a whole lot of sense. Again, we were thinking about sort of very subjective kinds of queries in doing this, but really reflects the kind of data, the availability of data in the ChatGPT model. So we're very interested in doing the same set of questions with other LLMs like DeepSeek as well. Another sort of really interesting example, just going to go through the last two real quick, is this is an example of trope bias. This is when we're looking at comparing neighborhoods. In this case, we're looking at neighborhoods in New York City. And if you're familiar with the neighborhoods in New York City, the ones that were identified by ChatGPT as having more beautiful people are wealthier, whiter, all the sort of standard social economic sort of hierarchies that we often see being reflected and showing up in this kind of backhanded way, so forth and so on, and the opposite in terms of the ones that were judged to be less beautiful. I might just end because I'm at the time I set aside myself in terms of happier people. I'm at the University of Kentucky, and I would probably disagree that people in Kentucky are, the saddest population in the U.S. But again, this is an exercise in sort of showing, what might we have in this. In this particular one, we're thinking about, how this also correlates quite strongly with things like recreational opportunities, income, and so forth. I mean, I guess I kind of agree with New York there, but so forth. And so this is our initial effort in terms of typology building. We're just starting this out, and we haven't. Well, anyway, I'll stop there and turn it over to Karen.
But North Dakota, man?
Hey, I mean, don't knock it.
It's like Scandinavia, right?
Sorry, 3 minutes.
Yes, 3 minutes. Okay, so I'm going to make a use case to talk a little bit more about this bias, but also work we're doing with Gen AI at the School of Cities. We have this issue that there's no centralized repository of housing ordinances. So how do you analyze what's going on in terms of regulation? And there's a great paper that did this using Gen AI by Bartik, 2023, and we've been playing and building on that. So on the left is our paper that is on Canada, where we have particular challenges because there is no actual legal database of municipal codes. So you actually only can just go to websites to get data that you need on bylaws. And then the second project is in California with my urban displacement project, which where we're funded by the Air Resources Board to develop inventory of anti-displacement policies across 550 California cities and counties. Huge job. And I told them, I'm never doing this for you again. Instead, I'm building you an AI tool so that you can update continually what's going on. So in Canada, this is a sample website. We're just trying to make sense of it. Is crazy just to figure out whether you can build an ADU there. We scraped, we probed with binary questions. In red are the ones that we got wrong because we couldn't find the answers on the websites. We actually found a way around it. And you can see this in the paper, which is under review in some journal that I don't even know what it is. It's a computer science journal. But what we did is we coupled a static database where we had scraped and searched for the answers, and we coupled it with a dynamic database, and that upped our accuracy rates to 92% doing this combined database kind of approach. So we're getting there in Canada. The US has been a little bit easier, again, because there are multiple municipal code databases that we can work in. They have built-in search functionality, so you can actually automate some searches for text strings. We've tried two different ways. We have the human method where we've developed a kind of a set of our students kind of point out which part of the code it's going to be in. The answer is going to be in. This is where rent stabilization is. This is where just cause eviction is. And so we go and look in those sections. Actually, what turned out to work better was a non-human method, a search method. So but instead of searching for specific municipal code, we search on blocks of text. So we generate huge blocks of text from what we've been able to collect from the ordinances, like anything on just cause eviction that we can find, and we plug that in to the chatbot, and it goes and uses that. It queries these municipal code databases to find the answer to questions. So we are now at 97% accuracy with this using Gemini 2.5 Pro, and we are able to answer binary questions, also some numeric and categorical questions as well. So it's gradually pulling up all the data we need on on 15 different anti-displacement policies across California cities. So black box bias, last slide. So it's kind of interesting to think about Matt's findings in light of this. We have availability bias working here because we only have so much of the bylaw text available online to actually search. We have pattern problems because we generate huge boxes of text to search on, but that's our patterns in our mind. We're kind of we're biasing what it looks for, and then averaging biases because many different people are possibly the same people are writing these ordinances, and so we're getting that lowest common denominator. So that's it.
Thank you. Thank you. Okay, any questions here? No? Okay, any questions online? Oh, we have questions, okay.
Can you talk more about like the 20 million prompts? How did you do that?
I mean, it's sure.
Yeah.
So you're obviously using an API.
So the question was how we did the 20 million prompts. Yeah, it was just through the ChatGPT API. It was it was a Python code, and you know, it's like any other API. You get a key. And in the case of this, you had to pay for tokens, and then depending on how long your query was, how long the response was, it costs different amounts of tokens.
But what, I mean, I get, yeah. So I guess my question is more specifically like, what are you using? Were you using ChatGPT to ask 20 million different questions?
No, we were asking 20 million different questions to ChatGPT, to the API.
But who has generated 20 million questions?
Just the Python code.
Okay,
So the 20 million, so it's like, imagine it's just like there's 200 countries, and so it's 200 times 199, you know, pairs times 300 different kinds of queries. It adds up like that.
I get it.
sorry, probably we don't have.
Right.
Yeah, but,
Really
yeah,
quick question.
just one more,
Sorry.
just one more
Was it
question.
the same- Was it ChatGPT knows it the same, all those questions were put in the same place?
My understanding, and this is, the quick answer is no. I mean, the key was always there, but the response should have been sort of treated as a separate kind of query. That's my understanding is how that works. If someone knows better, let me know, but they were independent queries.
I just asked Matt a really question. The North Dakota happy place question. I'm sure you've thought about this. Wonderful listing of all the bias types. Is there any way to sort of think about going in and saying, netting out these different biases, which is the happiest state? In other words, to sort of separate the signal from the noise. Is there any way to think
Yeah.
about that?
I mean, I think there's lots of, I think that's an interesting question that some of the conversations we're having right now, the goal for this first paper project was, getting this typology. And now we're trying to think about trying to get more at some of the better explanations, doing some comparisons and other things. That was too much for this particular project.
Thank you. And we have to move to next presenter. Renee, please go ahead.
Hi, everybody. So I've been running this AI in Canadian municipalities community of practice for, well, we're going into our 6th year now, and actually 2 people who are in the audience are also on our listserv. We have about 130 people on the listserv, most of whom are municipal data scientists. So they're employed by cities to do AI. So what I'm going to do is I'm going to present you with some
Sorry.
example.
Sorry,
What?
Renee, we have some issue on the speaker. Just a second.
Okay.
Come from you and
Yeah, I know, but it worked last time, but now I don't know.
Okay. Let me know when you can hear me. Can you hear me now?
Hold on just a second.
Can you try
Okay.
again?
Yeah. Can you hear me
Still
now?
This morning works.
Can you put the microphone next to the speaker? Would that help?
Can you hear me now?
Yeah, we can hear you because just the volume is not loud enough.
Okay. Okay. Hold
Okay,
on.
Yes.
Yeah.
You can hear me now?
Yes.
Yes.
Okay. Okay. Hi, everyone. I'm Renee Sieber. I'm from McGill University in Montreal in Canada. These are insights gathered from over 5 years worth of presentations at the AI in Canadian Municipalities Community of Practice. We have about 60 presentations now. And there are 130 people on the listserv, 2 of whom are in the audience. So hello, Karen, and hello, Pamela. So I'm going to give you a couple of examples before I go to the insights that we've gathered. So here's one. It's from London, Ontario. And the people there wanted to assess, these are practicing planners, by the way, and data scientists. And they were looking at addressing chronic homelessness in London, who becomes homeless once again after they've had temporary housing. What's important here is they built this in-house. This is deep learning. This is 2 hidden layer models, architecture that comes out of OpenAI. So rather than talk about their findings, it is interesting that they can do the AI in-house, and also how fragile it is because the data scientists in the city got sufficient knowledge to get a better paying job in the private sector. So example number 2, this is called Wild Edmonton. And Edmonton, the city, is quite large in Canada, but it exists at the urban-rural fringe, and they have a number of camera traps to try to capture wild animals. These are examples of moose coming into the city. And what was interesting for us were 2 things. One is that they had to go through a number of computer vision pre-trained models to find the appropriate model to use. They actually, one of the models they were using was finding giraffes coming into Edmonton. Obviously, there are not giraffes in Edmonton, but the pre-trained model was trained in probably a country in Africa. So it becomes really challenging to find the appropriate model that gives the right level of granularity for them, wildlife, yes or no. Also, it is the first and one of the very few instances of public engagement where they'd captured about 2 million images, and they didn't have enough people in-house to determine whether to validate the model output. So they relied on students and citizens to do essentially citizen science. Here's example number 3 is 311 non-emergency hotlines. This is one of the only instances in which people presented on generative AI. And I'm going to talk a little bit about this divide between machine learning and deep learning and generative AI. So here they were looking at efficiencies in directing 200,000 non-emergency calls per year. So this generative AI was doing classification, and it also was doing machine translation because it's a very multilingual city in Quebec. So they were doing translation on the fly to, for example, if someone called in was better in Cantonese than in French, then they could use generative AI on the fly to do the translation. Also, what was interesting was they started using what are called low-code and no-code platforms, or used the generative AI to through prompts to actually write the code for them. And what's interesting about that is that, you know what? Generative AI, when it does no code generation, is very good for software engineers, but not necessarily good when you have no prior coding experience. Example 4 is around procurement. So it is interesting how much procurement regs, whether formal or informal, differ amongst municipalities in Canada. So in the city of Montreal, you can do an internship and pay out for many interns $100,000 before you trigger formal procurement. For the city of Windsor, it is $10,000. And also, I find it very interesting that procurement is often used as a mechanism for economic development. Let's encourage small startups, so let's privilege them as opposed to some of the bigger vendors. Here's the last example. AI governance in the city of Toronto, Ontario. What often we'll see as people have shifted from apps to looking at governance models is they tend not to be separate from larger digital infrastructure plans that handle things like the integration of sensors. The city of Toronto has started to do municipal algorithmic impact assessments to try to understand any adverse or negative risks or harms from the use of these systems. It's still quite technocratic governance. They're still quite focused on getting the bugs fixed, as opposed to looking at larger issues of citizen engagement. But it is still largely in-house. There aren't a lot of these data scientists who are going out to vendors. They're building the stuff in-house, and they're creating effectively data shops and algorithm shops. So here are the implications for planners and governance. Why did I pick this picture? Because there's very much a gender dynamic at work. There are mostly men involved in this. Also, AI is often a sales pitch, a hammer in search of a nail, instead of identifying the problem first and then trying to see if the algorithms are fit for use. AI has been showing in Canada a maturation from shiny apps. Here's my cool new dashboard to issues of governance. You know, should it be in-house? Should it be outsourced? What parts to outsource? Are you engaging students? Are you engaging a local university? What about vendors, deployment, and possibly also their impacts? But it still tends to be, as I mentioned, very technocratic. You know, it's all about interoperability of sensors in a digital twin sort of way. And there's also some of this, we know which AI is best for our citizens, quote unquote, our customers, to improve service delivery as opposed to more fulsome citizen engagement. AI adoption is largely how-to or labor savings. I'm sorry for people who love generative AI, but we have seen throughout these applications that really the insights they're gathering is from predictive analytics, machine learning, and deep learning, not from generative AI, which tends to be used for summarization, but not for deep insights, or unfortunately, for saving on labor costs, as cities are looking to save money and unfortunately reduce the number of planners in a city. So AI governance, as I mentioned, AI governance tends to be about interoperability. Quality control, is the model accurate or not? Is one model better than another model? Or it is about legal compliance, as in, did we submit the right procedural fairness document? That we haven't gotten to the point, I think, where these models, these systems are fully integrated into the planning pipeline, and people have already talked about that. I think what is stunning is that these applications are not being built by practicing planners. And with all due respect to practicing planners, I think we need a new paradigm for planning, but not in the way you think it is. It should be in terms of we need more skills development always, but it should, what the paradigm is how do planners best fight for the resources they need to do their own AI development, because they're fighting with new types of employees in city government. They're fighting with data scientists. They're fighting with computer scientists employed by governments. And why we need planners, obviously, is because we think beyond the technology. We think about the larger political economy. Alvarez, Leon, and Rosen have written about how we have a new urban growth machine of distant platform and big tech companies that are really determining how we do planning in the city. And planners do have a special obligation to do advocacy planning and to engage citizens, and that's what we're good at. My own research is on the intersection of civic participation in AI. I don't have the time to go over the sheer difficulty of engaging people with AI or about AI. So what happens in cities is, one, we see a lot of responsible AI initiatives, a lot of AI good and for good initiatives, a lot of human-centered AI, but this is basically AI for inferring civic good, but not necessarily done with citizens. So a lot of civic participation, unfortunately, is fading away, and we need to bring it back. When we do see some public participation, it's AI as consultation. Hello, community, we're doing X. What do you think about what we're doing, as opposed to asking the community, should we be doing X in the first place? As I and I want to just end with, there are many transitive equations at work here when we talk about civic engagement that we need to be attuned to. One is that often municipal employees will think that if they improve service delivery, they will increase customer, not citizen, customer satisfaction, and therefore they will increase inclusion and engagement. as a natural byproduct. And that is, to me, a troublesome way of thinking about civic engagement. And lastly, that AI literacy, which often is advocated for as a part of participation, is let us tell you how good AI apps will be for you. And that should equal greater trust and greater social acceptance. And I've seen the stats on the US, but you probably don't know that Canada, amongst all OECD nations, has the largest skepticism in its population about AI. And I could tell you that AI literacy, in which you're trying to sell AI to citizens, is not going to increase trust and is not going to increase social acceptance. And we need to have a much broader conversation about how we effectively and meaningfully engage the public. And that is it for me. Thanks.
Thank you. Any question online? Probably you can unmute yourself. Okay. Yeah. Any question here in the room? No, I saw you have a question.
I'm not on the next.
Oh yeah. Any? Yeah. Probably. Yeah.
I don't know if I'm talking to all of you or to Renee right now. Hi, Renee. This is Jeff Boeing from USC.
Hey, Jeff.
As I understood your point at the end there, it's along the lines of the more people know about AI, the more skeptical they are of its adoption. And I wonder what that tells us more broadly about this agenda for AI in urban planning. If this is fool's gold, we're just looking at it the wrong way and naively, or if there is some promise, some way that we can be more knowledgeable about it and get benefits from it.
That's an excellent question and somewhat beyond the ability of planners to manage, because obviously we're in a transformative moment in which AI is having a massive impact on the economy, particularly on entry-level jobs. And we already know about a number of cases of algorithmic discrimination. So I think one of the challenges is, and I'd like to hear a lot more about the uses of predictive analytics and deep learning since I think that a lot of the concern is around generative AI specifically, as opposed to some of these more traditional kinds of AI. I don't know that that answers your profound question about how we're caught in this conundrum of we want people to know about this stuff, but what knowing about it entails amongst most government employees is let's tell you how wonderful the world will be, instead of embedding these larger questions of, oh, and you won't have a job besides.
All right, thank you. Yeah, now we have to move to next presenter, Williamson. And let me yeah, please.
Thank you. Hi, everyone. I'm Wayne Williamson from Macquarie University in Sydney, Australia. Renee's presentation then was a really good intro to my slides. I've been looking at an early adopter program in Sydney.
Wayne, could you move the microphone here?
Is that better?
Yeah.
Sorry. Looking at an early adopter program in Sydney. It's actually outside of Sydney as well. It's regional and metropolitan councils or municipalities. And just it was meant to run for 12 months. It's still running. I'm a big fan of the potential of AI, but this is a sort of a fairly critical situation in this project. So I'll jump right in. So the hype with politicians in Australia for AI and urban planning is real. It's full on. This is just a small collection of some of the newspaper articles that we're seeing rolling out recently. The tropes are all about cutting red tape or government regulation, speeding up housing supply, boosting planning efficiencies, cutting approval times, etc. There's no talk of innovative technology or great technology. It's all about how do we speed up housing? How do we make planners do their job faster? This is not new. This has come through in previous waves of technology as well, but it feels really hyped at the moment. When you see that situation, your mind starts to go to neoliberalism pretty quickly. The ideology has had a long association with planning. It is all about simple, more efficient, faster planning systems. In Australia, we often call planning an economic lever, and this is in hype mode at the moment. Now we're seeing this with this introduction of AI. So it's like we're hitting the perfect troika of neoliberal ideology, urban planning as economics, and AI as this market-driven systems of privatization and competition for all to see. There's another piece that I would like to point out was the adaptation bias. So when we talk about neoliberalism, adaptation bias often comes up where particularly government organizations will adapt and try to use technology to cover over deteriorating conditions or issues in the public service, which I'll circle back to on the next slide. So the early adopter program itself, which started about 18 months ago, started with collab workshops between the state government and municipalities to identify pain points in the development assessment, we call it in Australia, but assessment review process, and develop some case studies or use cases to apply AI products to. The middle, there's the 4 main use cases that come out. I won't go through them all in detail. Essentially, when you ask the planners, what's the problem with the system? It's the applicants. So all these use cases are, if they would just submit a better application, our planning system will work better. So essentially, that's a bit of an adaptation of bias happening right there. The third step is grant funding and tenders. So they put out an open tender for looking for any AI supplier who has a product that's ready to go. Essentially, the byline was, you must be market ready. 4 AI suppliers were selected for that panel. Then they actually put out an EOI to all municipalities. 16 of them answered the call. And then there was a weird sort of speed dating situation went on, and the 4 suppliers and the 16 municipalities were all matched up for a 12-month early adopter program. The solution panel is made up of 4 AI products. 2 of them, Adaptivate and Sienna Planning, straight up chatbots, probably sitting on the front of ChatGPT. And there's 2 what I call proven systems, Archistar and PropCode. Archistar is an Australian AI company or Australian IT company, and they do operate in some states in the US as well. California, I know of. But they are existing advanced GIS systems. Often they also have 3D modeling capabilities. They got themselves into this program by promising to add some sort of AI functionality. So my project really went I did interviews with the municipalities roughly halfway through, 3/4 of the way through their projects, asking 3 specific questions. And so the first one was, what are the existing AI products that can maybe used for development review processes? It became clear pretty quickly for the regional councils, so the councils outside of the major cities, the products that were on the panel are very much focused on code assessment, which is easier to feed into the AI products, but they rely more on merit assessment because of environmental constraints, where there's a bit more flexibility and a stronger assessment is needed. Metropolitan councils are also really interested in the proven products. Where they had high workloads, they weren't interested in the chat bots because their IT staff had really strong concerns about how they would be implemented, and the 2 chatbots that were chosen were relatively unproven. So there's very strong concerns. The suppliers themselves were also really unprepared for the trial. There was no communication before. They had a short period of time to get involved, and a lot of them were trying to do the project with the municipalities and update their software at the same time. The other thing that came out very clearly was that the existing software products that are out there have been developed for the private property development industry. They are not developed with government in mind. So there's only, essentially, the project has found there's only a small handful of products in Australia that can be implemented and used quickly. The second question is the human labour required by the planners. This was pretty bad. So the resource intensity was very high. There's a lot of manual checking with the government's legacy systems. There was really 2 distinct pathways: established tools using vendor data, where they've harvested and cleaned, etc., or chatbot products where they will only be trained on public data. This is fine, but it then becomes a problem because the municipality loses control or access or accuracy of their data, and they are the legal owners of this data. So they are literally handing over some of their responsibility. The chatbots were also a very low risk approach. There was no interest in giving them access to any internal data in these government agencies. The risk of data currency and hallucinations was just too high. The other not new issue is anytime you look at introducing technology to planners, the first thing they'll ask is what happens when the legislation changes or the regulation changes. So there was a strong piece by the AI suppliers trying to convince the government agencies that change management will be in place and this won't be a problem, but it is an issue that planners go to over and over, probably from experience. So the key challenge is balancing the efficiency and control and data quality control and compliance. The third and final question was potential implications of existing management processes. And the project, there really is an ongoing debate about what the goal is. Are you trying to improve the quality of the development applications coming in from the customer, or is it just customer convenience? It's an open question. It's more, or in another way, are you trying to make it easier for planners and assessment officers, so the internal side, or are you trying to make it easier for the homeowners and developers, the external side? It's an open and ongoing question that has come up multiple times through this project. Most there hasn't been any great results come out of this. There's been about 3.5 million US dollars spent on this project. Hasn't been any strong results at all. And because most were looking at a really soft launch strategy with very restrictive rollout due to trust and accuracy issues. The other thing that's not new as well is this is the same technology as before, where you need change management, you need work stops, you need staff engagement. So it's not just a technology adoption, it's a cultural business process change at the same time. So I'm done. The takeaway is the hyper rhetoric is very similar to previous waves of technology, and many of the issues and challenges of introducing that technology into organizations before still exists. And if you're interested, there's a book chapter coming out early next year on that project.
Thank you. Yeah, we have a question online.
Yeah, so I really love that presentation. I have one question for you in one word: liability. And this is where generative AI massively differs from other software we've used. And we have a really good example of how a chat GPT can expose you to massive liability. So did anyone bring that up, and how did you address that?
Yeah, that's one of their big issues. That was the soft launch stuff. They were so concerned about it. Yeah, there's no answer at the moment, but it's a key part of the concerns.
Okay, thank you. I think that's the end of session 4, and yeah. Okay, we're gonna resume session 5 at
5 minutes.
5 minutes. Yeah. Yeah, 2:50.